Hello, in this section, we will introduce you to deep learning. What is it and why is it powerful and the concepts powering them. Our brain is the inspiration for today's automated and intelligent systems. Here you see the picture of a neuron cell in our brain. It takes inputs from the neighboring neurons, processes it and gives some output. As simple as it is, right? But what makes our brain powerful? Billions of such neurons process and communicate with each other to form a powerful network which is enabling us to learn, create, think and reason. This is called a neural network. Mimicking this, we created a computed version of neuron called artificial neuron, but the purpose is same. We also stack many of them like in our brain to form an artificial neural network. So this is the basic structure of an artificial neural network. Before we go any further, let's look at the difference between machine learning and deep learning. Deep learning is an advanced version of machine learning which performs automated feature extraction. The success of machine learning lies in the good feature extraction, which is a difficult and at times impossible task. This process is solved by deep learning, which performs automated feature extraction. So how these neural networks work and why are they powerful? The main power of them lies in the non-linearity. As you can see in the picture, this curve which is in the S shape can be seen as a combination of two or more simple curves. An activation function at the end of each neuron converts a linear input to it into a non-linear curve. When these curves are combined from many different neurons, they can form many complex shapes and approximate any function. So, an activation function is the base for a neural network. Without an activation function, there is no neural network. There are many activation functions. The first one you see here, sigmoid, which is like an S-shaped curve. Its output lies in between 0 and 1, hence it is used in generating probabilities. The right side here you see is a hyperbolic tangent function. It is same like a sigmoid except that its output is -1 and 1. It is more dominant over sigmoid because of its zero mean property. But these two suffer from a problem called vanishing gradient problem, which you will see in the future sections. The most common activation function we use today is a rectified linear unit, which is easy to compute and solves the problem of vanishing gradient. As you can see, it's just outputs the input if it is positive or 0 if it's negative. There are different versions of ReLU like leaky ReLU and exponential ReLU, which has linear and exponential slopes on the negative sides respectively, serving different purposes. So summarizing what we have learned, large neural networks form basis for deep learning. These neural networks have many features, like they perform an automated feature extraction unlike machine learning techniques. They can approximate any complex nonlinear functions. Their accuracy increases with the size of the network. There are also many types of neural networks depending upon the purpose. Artificial neural networks, convolutional neural networks, and the recurrent neural networks. We will see them in a great deal in the future sections. Thank you.